Hello everyone and welcome to MV Tutors. I'm Tulu and I'll be looking at the topic of functions. Alright, so this was basically covered in grade 11, but I thought it would be nice to just go over it, especially since grade 12 you guys are doing inverse functions and you need to understand functions from previous grades. Alright, so please don't forget to like our videos and also subscribe to our channel. And if you want to make a booking, if you want a private lesson, please do visit our website on www.mvtutors.co.za. Let's get to the lesson. So, what is a function? Alright, so basically it is the relationship between two variables where an independent variable, independent x, okay, the x-axis, so x values are independent, and that independent variable has exactly one dependent variable. So that is what makes it a function. You've probably heard of a one-to-one function, okay? That would be like probably in the form of a straight line. All right, so if you were to, just gonna draw roughly here, if you were to have your y-axis and your x-axis, and you have a straight line over here. So for every one x value, you get one y value. Okay, every one x value produces one y value. So every one independent variable, it has exactly one dependent variable. Okay, so that is a one-to-one function. And sometimes you have a many-to-one function. And a many-to-one function would be probably in the form of a quadratic equation. Okay, so let's say you have a parabola, quadratic equation. Okay, so here for one y value, okay, you basically have two x values. So it's a many-to-one function. Okay, now when it comes to a many-to-one function, you can only have one dependent variable, like in this case the y value, and then have two independent variables. Okay, so for one y value you can get two x values. So now let's have a look at maybe if you had a circle. Okay, not so nicely drawn, but let's say you have an x value there. Okay, so if your x value, and you take it up, you're gonna have a y value here, and if you take that to the circle, you're gonna get a y value there. If for one independent variable you get two dependent variables, that is not a function. Okay, so a circle in this case, it's not a function. For it to be a function, you'd probably have to cut it in half. Even for a parabola, if you were to get the inverse of this parabola, and it would look something like that. Okay, you would see that for one x value you actually get two y values. All right, and because of that, that cannot be a function. And you would find that they would ask, how would you make this a function? Well, basically you can just cut this part off and you have just one side of it, and that becomes a function. Okay, so that's basically what a function is. Okay, for one independent variable you get one dependent variable. That's a one-to-one function. And also for one dependent variable you can get two independent variables, and that's a many-to-one function. Okay, but as soon as for one x value you get two y values, you don't have a function anymore. Okay, but it's allowed for one y value to get two x values. I hope I didn't confuse you there, but there is a video where my husband covers inverse functions and does cover in detail what a function is. But basically, in summary, a function is a relationship between two variables where the independent variable, that's x, has exactly one dependent variable, y. Okay, so we're going to first start with the linear function. Then we're going to carry over to the quadratic function. Thirdly, the hyperbolic function, and finally, the exponential function. And that's all you really need to know. They like asking this in the paper one questions, or I think question like 5, 6, 7 or something like that. So please, if you understand this, you can score a lot of marks. I know for a lot of people this is a tough section, But if you really understand the functions, guys, it's gonna go well. I promise you. So with a linear function, that's basically a straight line graph. And you would be familiar with the equation y is equal to mx plus c, okay? And in this case, your gradient, that would be m. So m represents your gradient. You can have like a flat gradient or a very steep gradient, okay? You can either have a negative gradient, negative meaning in your Cartesian plane, okay? If you have a Cartesian plane over there, and when you go from left to right and you're going down, okay, or rather let me do this. If you're going down from left to right, you have a negative gradient, okay? But if you're going up from left to right, you basically have a positive gradient, okay? So that is basically that with the gradient. That would be m. And then the y-intercept. Okay, maybe I was too quick to cancel that. Okay, let's just go back again. Let's just use a negative gradient in this case. So your y-intercept, basically that's where your graph intersects the y-axis. And as you can see over here, the graph intersects the y-axis right over there. So that's basically your y-intercept, okay? And if you want to get your y-intercept, do you see on the y-axis, that is where x is 0? Yes. So if I were to have my equation there, y is equal to mx plus c, and I wanted to get the y-intercept, I would make x 0 because I know that x is 0 on the y-axis. And basically, I would find that my y-intercept is c. Okay, so y-intercept, that is basically where you have c. Then you get your x-intercept. Okay, that's basically where the function cuts the x-axis, and it cuts it over here. Okay, and on the x-axis, that is basically where y is 0. Okay, so again, if you were to calculate the x-intercept, you have your equation here, y is equal to mx plus c. You would make y 0. Okay, and then if you were to calculate what the x-intercept is, okay, you would then take negative mx to the other side, and basically x would be negative c over m. Okay, you can basically work it out, okay? So that would be your x-intercept, okay? Then we talk about the range and the domain. All right, guys, the domain and range. Okay, so whenever we talk about domain, that's basically when you look at the x values of your function. So let us just say I have my function over here, and I have restricted it to reach only these points. And let's say my graph starts at -4 and ends at 2, for argument's sake. So if I were to say, they were to ask, what is the domain of this function? I'm basically looking at my straight line graph and inspecting which x values are for this function, if that makes sense. So this function that I have, over which x values does it exist? Okay, and if we were to say it, okay, I would say x is an element, okay, and I'm going to use square brackets because it does start there at -4 and it ends at 2, okay? You would normally indicate that with a closed dot, okay, if you're including it. But if you didn't include, if you were to use round brackets, then you would indicate it with an open circle. Okay, but that's basically your domain. But normally when you do these questions on functions, they hardly ever restrict the domain. You can have your function go as far as possible as you like, okay? So what does that mean? It means that it can go all the way, like there is no restriction. So in that case, you would say that x is an element of R, okay? So basically, or you could say x is an element of -infinity to +infinity, because it goes from the negative side to the positive side, and we can't define where it stops. It just goes. It can go. Right now we are limited by this wide screen, but it can actually go all the way to infinity. Okay, and then we talk about the range. Even with your straight line graph, your range, you can see the y values of this function, they can go on and on and on. Okay, so again, you would also put there that y is an element of R, or y is an element of negative infinity to infinity. Had you applied the restrictions like I had earlier on, okay, and we know that this function here, it probably ends there at 5, and there it ends there at -3, then you would say y is an element of negative. You start from the lowest value, please don't start with the high value, -3 to +3 to +5. Okay, so that's basically the domain and the range. I remember when they introduced this part to us in grade 10, I was confused, like, what is this domain thing? And you go to the dictionary to look for a meaning, and it just throws you off. So when you think domain, think of the x values where a function is applicable. Okay, when you think range, think of the y values where the function is applicable. Okay, so basically these are the questions that would ask for a linear function, like what is the gradient, calculate the y-intercept, get the x-intercept, describe the domain and the range, and so forth. And linear functions, guys, these are the easiest. Okay, so please, yeah, do well in them. Now we're going to have a look at how to actually determine the linear function equation, all right? And they can give you different kinds of information, and you have to get the equation for it. So firstly, we're going to look at the 2-point form. Let's say they give you 2 points on a straight line function, and you need to get the equation of this line. Okay, so for example, and we're going to use this equation here. Okay, so this is where it's applicable. And if you actually take a closer look, you know how the gradient is actually your change in y over change in x. So I'm just putting it out there. This looks like the gradient equation, but yeah. So anyway, if they give you 2 points and you're supposed to get the equation of a straight line, you can definitely use this equation, okay? I normally have one way of calculating the equation of a straight line, and sometimes it's very long. As long as I have a gradient and a point, I can get the straight line function, but this helps. It actually makes life quicker, okay, and shorter. You don't have to do it the long way. But if you have 2 points, let's say we can sketch it. Oh, sorry, let's just plot the 2 points. So for P, I have -1 and -5. So it's somewhere here. And for Q, I have 5. So the X is 5 and the Y is 4. So it will be somewhere over here. Okay, then I draw a straight line between the 2 points. I hope, yes, it worked out. Yeah. Okay, so let's just expand this a bit. But yeah, that's basically where Q is and where P is. And I need to get the equation of this line. I need to get it in the form y is equal to mx plus c. So using this equation over here, I will choose this as, okay, I will then say y minus yp x minus xp, because I'm working with p and q, not 1 and 2. And then I have yq minus yp over xq minus xp. Okay, and then we have over here the y coordinate of p is -5, so I'm just going to make that a plus. And the x coordinate of p is -1, so I'm just going to make that positive. The y coordinate of q is 4. The x coordinate of q is 5. The y coordinate of p -5. Okay, and then that becomes a positive. And the x coordinate of p is -1. But then, yeah, it does that. So what do I have over here? So I continue to have y plus 5 and x plus 1. There I have 9 and I have 6. So I'm basically going to cross multiply. Okay, and then we will work out what. So I'm going to take 6 over that side. So I have 6 times y plus 5, which is equal to 9 times x plus 1. Okay, And we are seeing here that actually whatever I calculate, I need to make sure that I have a positive gradient, because from left to right, we're actually going up. So it has to be a positive gradient. If I get a negative gradient, I did something wrong. Okay, so what I'm going to do, actually I shouldn't have taken 6 to that side. I'm going to take 6 back to the other side. Okay, so I have y plus 5 is equal to 9 over 6 x plus 1. Okay, then I'm going to take the 5 to the other side. So I basically have 9 over 6. Let me just multiply this in. Plus 9 over 6 minus 5. What is 9 over 6? I don't know. I can simplify it though. It's going to be 3 over 2. Alright, so that makes it better. That is 1.5. So if I have 1.5 minus 5, okay, that's like saying, minus 5 plus 1.5. That will be minus 3.5. Okay, so yes, my gradient is positive. That's cool. And my y-intercept, okay, remember we have y is equal to mx plus c. My y-intercept is 3.5. And look at that, guys. Negative 3.5. It does cut it at negative 3.5. So I'm glad we got this right. Yeah, well, this is a straight line function. We should get it right. Okay, so that's basically how you would get the equation of a straight line if you just have 2 points. Okay, now there's another method, which is the gradient point form. And in this case, you're going to use this equation over here. Okay, and basically here, they would have to give you a gradient and a point. And what you do, you just pretty much substitute it in the formula. Okay, so we have y minus y1. So basically, the y value of that point, which is 1. And then you have m, so already have given us the gradient, which is negative 1/3. And then you have x minus x1. So minus minus 1, that will be a plus 1. Okay, so this one is a bit simple. Alright, so you're going to have a negative 1/3 x and a negative 1/3 plus 1. Okay, so finally your equation, if I have negative 1/3 plus 1, just think of that 1 as 3 over 3. Okay, so basically you have negative 1 over 3 plus 3 over 3. You're going to end up having 2 over 3. Okay, and that's basically your equation in the form y is equal to mx plus c. Now, a third way of doing it, basically it is the gradient intercept form. That is the standard form, okay? The one that I normally use, the one that I like. So basically, you know your form, your equation is y is equal to mx plus c. If you have a gradient and you have a point, basically you can substitute those in the formula so that you can get the value of c. Okay, and once you have the value of c, you can go back and write the equation. Okay, so what do I mean by that? So I have a point, right? So I'm going to substitute 7 in the place of y. In the place of m, I have negative 2. In the place of x, I have negative 1. And then I'm left with c. Okay, so I then have 7 is equal to 2 plus c. And therefore c would be equal to 5. Alright, great. So therefore if I were to write down my equation, I know that the gradient is negative 2x, and I know that c is 5. Okay, I feel like this is like the quickest, simplest way, but it really depends. What are you given and what information has been given? All right. And then, so that is if you were given a gradient and a point. But what if you were given 2 points and no gradient? Okay, I would go calculate the gradient. But if you have 2 points that are given to you, remember you have y is equal to mx plus c. So that would be basically for p. Okay, those values for p. And then again y, I have q is equal to mx plus c. Okay, so now what I'm going to do, I'm going to have 2 equations, okay, where I have my unknown gradient. Okay, so I'm going to substitute for p here. So for P, I have -2. I don't know what my gradient is. No, sorry. My y value is -7. Okay, my x value is -2. And then I have C. So I have two unknowns, two equations. Okay, this seems like a very long way of doing it, but I want to offer you alternative ways so that when you get to the exam, you are not stuck. And this is still like straight line functions, so this should be like easy. Okay, so for Q, the y value is 8. We don't know what the gradient is, but the x value is 3. Okay, plus C. So if I were to simplify that, I actually have 3m plus C is equal to 8. This is my second formula. Here I have -2m plus C is equal to -7. Okay, that's my first equation. So then I need to solve simultaneously. Okay, this way is very long. This is very long. I don't like it already. But like I said, need to offer two ways of doing this, or many ways of getting the equation so that you're not stuck. Okay, so what I can do, I can put it in terms of C. So I could say C is actually -7 plus 2m. Okay, that's my third form. So I can say substitute 3 in 2. Okay, so I have C, so now 3m plus C. I know that my C is -7 plus 2m. All right, and that is all equal to 8. Okay, so yeah, this is what we have. I'm going to keep the m's on one side, so I have 5m, and I'm going to take 7 to the other side. I have 15. All right, so m is equal to 3. And once I have my gradient over there, I can then get what the value of C is. So I can take m into my third equation. So C is equal to -7 plus 2 times m. 2 times m, that's 6. 2 times 3, right? So C is going to be -1. So therefore, my equation is going to be y is equal to m x plus C. Okay, so guys, I've given you how many ways of calculating? Basically 4 ways of getting the equation of a circle. If you have 2 points, or if they have given you a gradient and a point, there are many options. You choose which one works for you, but through practice and doing it often, it'll be easy. So when information comes to you, you'll be on a roll. Okay, so now we get to the inclination of a line. This is more basically for paper 2, but they tend to ask questions in paper 1, so just make sure you understand. Okay, basically the equation then for inclination of a line, that would be tan theta is equal to m. And m is your gradient, right? Gradient, which is change in y over change in x. Okay, and this is applicable really for I've restricted the domain now between 0 degrees and 180 degrees, okay? Between 0 and 180 degrees. If this is your Cartesian plane, sorry about that. So yes, so basically if you were to have your Cartesian plane over here, okay, you can see that for you to calculate the inclination of a line, you're really limited to having it from 0 to 180 degrees. Okay, you can't go beyond that. Yeah, so basically you can have either an acute angle, like in this case, an acute angle would be as a result of a straight line graph that has a positive gradient. Okay, you can also then have an obtuse angle, in this case over here, and that would be as a result of a negative gradient, okay, because from left to right it is going down. All right, so yeah, I've just indicated there, like that would be m is equal to 1. So if you were to get, okay, now I need a calculator. So if I were to have tan theta is equal to 1, okay, then for me to calculate it, I would have to put it like this in my calculator. Okay, I think this one is easy. Tan 45 is equal to 1. Okay, but the other one, not so easy. You would do the same thing if it's a negative. Oh, actually, there's a trick. If it's a negative gradient, okay, remember that tan of a negative angle is actually equal to negative 10, and 10 is negative in the fourth quadrant as well as the second quadrant. Okay, now this is paper 2 stuff. But if you were to calculate tan theta equal to negative 0.7, and if you put it in your calculator, you're probably going to get a negative angle. Okay, negative angle over here, and that negative angle would actually be this section over here. Okay, so for you now to get alpha, which is the inclination of the line, which is what we're looking for, do you see this is angles on a straight line? So then you would have to then say 180 minus that angle that you got over there. Okay, so please remember this. Whenever you're calculating the inclination of a line where your gradient is negative, once you get that negative answer, don't leave it at that. We don't want the negative answer. We want the positive obtuse angle. So you're going to have to take 180 degrees and subtract. Okay, another thing. Let's say, let's use a simple example. Let me just use negative 1 for simplification's sake, because I don't want to bring up the calculator now. So if I were to have, just bring this up, if I were to have tan theta is equal to negative 1, and I get that theta is negative 45 degrees, so that would be the negative 45 degrees over here. But I want alpha, okay? I want alpha over here. So how am I going to get alpha? So I know that alpha is going to be 180 subtracted by the positive value. I'm not going to say 180 minus 45. I'm going to say 180 minus 45 degrees. Okay. The minus 45 tells you that it's in the fourth quadrant. Okay, so please don't forget that. So 180 minus 45, that will be 135 degrees. So then I know alpha is 135 degrees. That is how you deal with negative gradients when you're calculating the inclination of a line. Don't give or don't leave the answer as a negative. Actually present to your marker the positive obtuse angle. Okay, and then lastly, we're just going to talk about parallel lines versus perpendicular lines. The one thing I wanted to really outline here is when you have parallel lines, the gradients are going to be the same. So line 1 will have a particular gradient, which is 0.5, for example. No, negative 0.5. Remember now, from left to right, it's going down. So I would have m is equal to negative 0.5, although it looks kind of steep for 0.5. And also for line 2, because they are parallel, the gradients are going to be the same. Okay, so if they were to say, if they gave you an equation of a line for L1, and you already saw the gradient is negative 0.5, and then they asked calculate the equation for L2. If you have a point and you know that when lines are parallel the gradient is the same, you can definitely calculate the equation. Okay, same thing if you have perpendicular lines. All right, well, it's not the same in that the gradients are equal, but if you have an equation of one line, and then let's say they said here y is equal to 0.5x plus 2, and here they gave you a point -1 and 2. I'm just making up values here, and they wanted you to get the equation for L2. Well, basically for perpendicular lines, the gradient for 1 and the gradient of 2, when you multiply them, their product is going to give you -1. Okay, so I know the gradient for L1 is 0.5. I'm trying to figure out what the gradient for L2 is, and if I take it to the other side, 1 divided by a half is actually 2. Okay, if you if you divide one by half, you get two portions. So that would be, but it would be -2. Okay, and that makes sense because from left to right you're going down, so it should be a negative gradient. So then you have your gradient, you have your point, and I've showed you before what you do when you have a gradient and a point. You can definitely calculate the equation of a straight line. And yeah, I think that's basically it for straight line. Yes, that's basically it for straight line graphs. This is, I think straight lines were introduced probably grade 9, if not 8. Okay, but I thought let's just go through it because it is asked over and over again, and it's something that you shouldn't forget because maths is cumulative. All right, so let's go to the next function.